This is the solution video for Unit 7 review, problem number 27. A particle moves along the x-axis so that its velocity at any time t is given by v of t equals sine of 2t. At t equals 0, the particle is at the origin, right? So that means its position is 0 at t equals 0. For t between 0 and pi, find all values of t for which the particle is moving to the left. All right, so what does that mean? Moving to the left means that the velocity is negative, right? So we're going to set the velocity equal to 0. So sine of 2t equals 0. So now when is sine equal to 0? Sine is 0. Uh, right? At 0, pi, 2 pi, right? So we could say pi n, right? So we're going to divide by 2. So t is equal to pi over 2 n. Now, if we're going from 0 to pi, that means t would be at pi over 2 n at 0, pi over 2, and pi, right? So the two endpoints and pi over 2, right? And so now I want to do a sign analysis. So I'm going to put 0, I'm going to put pi over 2, and I'm going to put pi, and I have the sine of 2t. All right, so now I have 0, 0, 0. All right, so pick a number in between 0 and pi over 2. So if I plug a number like that, like how about pi over 4? 2 times pi over 4 is pi over 2. Sine of pi over 2 is positive. And then pick a number in between pi over 2 and pi, uh, like 3 pi over 4, right? And so 2 times 3 pi over 4 is going to be 3 pi over 2, and sine of 3 pi over 2 is negative, right? So we get that the velocity is positive here and negative here. So when is the particle moving to the left? That would be from pi over 2 to pi, all right? Now, remember, that is kind of an older question, right? But nonetheless, we still need to make sure we can do it. All right. Write an expression for the position of the particle at any time t. All right. So remember that we're given the velocity v of t is sine of 2t. So we need to recognize that v is actually the derivative of the position. So ds dt. So we're going to multiply by dt, and we get that ds is equal to sine of 2t dt. All right, and so now we're ready to integrate. All right, so the integral of ds is s. Integral of sine of 2t, I'm going to need a u substitution of 2t. So du is 2 dt. So I'm going to need a 2 with the dt and a 1 half on the outside. So I have 1 half the integral of the sine of u du. All right, so now let's head up here. So s is going to be 1 half integral of sine, remember, is negative cosine of u, which is 2t, all right, and then plus c. All right. Now, we are told that at t equals 0, the position of a particle is at the origin. So that means that s is 0 when t is 0. So negative 1 half cosine of 2 times 0 plus c. And so 0 equals cosine of 0 is 1. So I get negative 1 half plus c. So c is equal to positive 1 half. So that means that the position of the particle is s of t equals negative 1 half cosine of 2t plus 1 half. All right, so that is the answer for B. All right, and now C says for t between 0 and pi over 2, find the average value of the position function. So now we're going to use average value. So f of z equals 1 over b minus a, so 1 over pi over 2 minus 0 times the definite integral from 0 to pi over 2 of our answer here. So that'd be negative 1 half cosine of 2t plus 1 half, and then you're going to integrate all of that with respect to t. All right, so now we have a little bit of work to do here. All right, so pi over 2 minus 0 is pi over 2. So 1 over pi over 2 is 2 over pi. So 2 over pi times this integral. Now, we're going to have to integrate these two terms separately, right? So now I'm going to have the integral from 0 to pi over 2 of negative 1 half cosine of 2t, right? dt, and then plus the integral from 0 to pi over 2 of 1 half dt. All right, so now two separate integrals, and all of this is going to be multiplied by the 2 over pi. All right, now for the first integral, we're going to need a u of 2t, just like we did a minute ago. So du is 2 dt. So I've got the 2 over pi here, okay? Then I'm going to have to put a 2 with the dt and a 1 half on the outside. So I have 1 half integral from t equals 0 to t equals pi over 2. Now we also have this negative 1 half that I'm going to bring out front. So I have a negative 1 half times the 1/2 from the u substitution. And then I have cosine of u du. Remember, we put a 2 with the dt and the 1/2 on the outside. Then I've got this plus, now this part, so the integral of 1/2 dt is just 1/2 t, and then we're going to evaluate that from 0 to pi over 2, and then we make sure that the 2 over pi is going to get distributed. All right, so a lot of work on this one. All right, so 2 over pi times, all right, -1/4. All right, integral of cosine is sine of u, right? Now, sine of u, well, u is 2t, right? And then we need to evaluate. Now, I never did this, but let's go over here on the side. If u is 2t, what is u when t equals pi over 2? Well, that would be 2 times pi over 2. So the upper limit is just pi. So we're going to evaluate from pi there. And what is u when t is 0? Well, 2 times 0 is just 0, right? So we are going to go from 0 to pi. All right, and then I have plus 1/2 t from 0 to pi over 2. All right, and then we're going to distribute the 2 over pi. So 2 over pi times. All right, so -1/4 sine of pi minus -1/4 sine of 0, right? So that's that first part. And then I have plus half of t, which is pi over 2, minus half of t, which is 0. All right. So now 2 over pi on the outside, -1/4 sine of pi, which is 0, plus 1/4 sine of 0, which is 0. Right. Let's see. And then I have plus 1/4 of pi. So that'd be pi over 4, and then minus 0. Right. So all of that, right? That's just 0, 0, 0. So 2 over pi times pi over 4. So the pi's reduced and I get 1/2. So the answer to C is 1/2.